Hi, this is David from Dark Ivy Consulting, and today I'm talking about putting building management systems into the cloud, well architected. I'd like to show you one of the things I've been working on this year. I've been helping people take these servers that are running their building management systems and migrate them to the cloud. We call that a lift and shift. And there's a lot of good reasons for migrating to the cloud. This isn't going to be a demonstration on why people should use the cloud. There's plenty of reason to do that and tons of information about it at this point. This is more about what are the benefits of moving a building management system to the cloud? Why should people be using the cloud for their building management system? And what things should the installer do when configuring and deploying and maintaining that server? It is a lot different. You can do it the same way you've always done it. What I'm showing is how to do it well architected. Let's take a look at what a typical building management system might be doing. So a typical building management system has several services on it, and it's very typical to see them all installed onto the same server. Reasons for it: servers are expensive and they take up a lot of space. You've got to house them, cool them, maintain them. So we end up with a building management system that operates a facility that is critical, yet it's all installed on one computer. The BMS server typically contains a web server of some kind for operator access, and a data historian for collecting information about the facility and storing a historic record of it. And then once that data has been collected, it usually runs through some kind of energy reporter. Then reports are generated based on the usage of the system, and those reports are sent out to stakeholders. Also, this computer tends to end up being an operator workstation on top of all of that, meaning that there are people that do daily tasks on that server. And these days it's also likely that the server has BACnet Secure Connect installed on it. BACnet Secure Connect facilitates the incoming connections, encrypting the traffic and helping with security. Having all of these services on one server, I guess it makes sense in a terrestrial sense, but once you move to the cloud, we no longer need to do it this way. I think it would be a mistake to simply migrate this server to the cloud using a terrestrial configuration. These services are all on the same computer for reasons like the cost of the equipment and housing the equipment. These reasons don't mean so much when we move to the cloud. What are some of the liabilities or challenges that I've seen with this type of configuration? Well, primarily, from a cybersecurity perspective, these servers lack defense in depth. That's a critical element of cybersecurity. And building management systems and automation systems in general lack this concept. The concept of defense in depth is the idea of having numerous layers of protection. And building management systems lack that. A typical building management system, if you get access to any of it, you get access to all of it. I hear all the time building management techs say things like, well, if the person gets physical access to the computer or physical access to the network, then, that's not my problem. That's a physical issue. That's a security issue, a physical security issue. And of course, we will have no other defense in place. That's not paying attention to all of the tools we have available to add layers of defense to a system. These local servers also tend to lack fault tolerance. I can't count the amount of times I've seen one of those services, say the energy reporter service. It develops a fault, Suddenly it's taking up 100% of the CPU, and it takes the web server offline. There's no fault tolerance in this single server design, and it's almost like they're hoping it's not going to break. With cybersecurity, we don't hope things don't break. We plan for them to break. Automated backups are rarely done. Backups should be automated and not manual. Most importantly, it's the databases that need to be backed up on a regular basis. Is that data used for reporting your energy usage to somebody? Maybe it should be backed up. Principle of least privilege is another tenet of cybersecurity. And this is the concept of giving people the least amount of privilege they need to do their job. Principle of least privilege shows up in the sense of people log in as the administrator to do daily tasks on these local servers. I see that all the time. If you have principle of least privilege, you would be creating user accounts for all of the users, which give them the access they need to do their job. Having everybody log in as administrator means that anybody who accesses the system, maybe they steal the credentials, will be able to do whatever they want to the server, maximizing your blast radius. These servers also have a high initial cost, and I think that's a big factor these days. When people decide that their building management system is ready to go, they look at the cost of a new server and what that's going to give them, and they decide that they don't really want to pay thousands and thousands and thousands of dollars up front for a server that won't necessarily be utilized for several years at the level that they just paid. You see, when you buy a server, when you provision a server, you provision it for its end of life need, not its day one need. And this goes with the high initial cost. Often these servers are incorrectly provisioned. What typically happens is people buy the most expensive computer that their budget allows, and they hope that it will last many years. But they continually add sites and they continually add systems to the server, and eventually it bottoms out. And this is a really big one in our industry as well. We lack visibility. We lack visibility to our network traffic, and we lack visibility into the health and performance of our server. There's no need to lack visibility. It's just omitted. This is an example of what I have been putting forth on the left. This is what I would refer to as a well-architected BMS system. First of all, you'll notice that it's not one computer. There's no need in the cloud to host everything on the same computer. We don't have the limitations of space, storage, upfront cost, cooling, maintaining. All of that we've outsourced to the cloud provider. So let's take advantage of this. You'll notice at the bottom I've got a cloud public subnet. That's where my application servers go. These are the customer or user facing servers. I have a separate subnet called the private subnet. This is where the database servers go. This is where the critical information is kept. The database subnet, the private subnet, it's private because it literally has no internet access. It might be in the cloud, but it's without internet access. That's because the database servers are critical. And if a hack occurs, that's the meaningful piece. There's no need for the database servers to be internet connected. Instead, the cloud public subnet is able to access the database servers and only the cloud public subnet. So we have a public facing network which contains a server for each service, for each building management system service. And this is a great way of doing it because we don't have an issue anymore of one service taking another offline. Instead, what we do is we correctly provision each application server to the needs of the users. And this is what makes cloud so great, is that we can tune these servers over time so that we're not paying too much or we're not under provisioning and failing to meet service requirements. The security policy between the public and private subnet is essential here. You see, I've got a security policy in place that denies all traffic to the database servers except for SQL requests and remote desktop protocol, optional, from the public subnet. So the application servers will be able to talk with the database servers fine, and that's going to work great. The clients, the users, the controllers, the devices, none of that needs to talk to the database server directly. Also, very important, I have nightly backups, automated nightly backups. And that makes sure that I've got a copy of all of my databases, and I go for 7 days at least of nightly backups. When deploying a database in the cloud, it's really important that you correctly provision the proper storage type. There are multiple options to pick from, and you want to make sure that you're storing your data on the recommended type of drive for a database. Cloud storage drives are impermanent, and the default one is not recommended for databases. I've locked down the remote desktop protocol on these servers. I don't want anyone to be able to remote desktop protocol into these. On my application servers, these are the public-facing servers, I do not allow remote desktop protocol to occur from anywhere. That's the default. What I would like is to specify where remote desktop protocol connections can come from. Ideally, I would specify an office. Only connections from remote desktop connections from my office are allowed. Or only remote desktop protocol connections that come from my VPN connection, my VPN exit point, are allowed. It is not a best practice to allow remote desktop protocol from anywhere. I'm using Cloud Public Subnet for my user accessible services. And some of these systems are critical. For example, my BACnet Secure Connect connection, I really don't want to lose that. And cloud services allow me to deploy a load balancer and install redundant servers. I might want to install my BACnet Secure Connect across multiple availability zones. And this would create a level of redundancy in my system. If I need 365, 24/7 uptime, I need redundancy. This is a big one. I see default passwords all over the place. I think I get why it's happening. The installation applies the SQL password, and nobody goes and changes it afterward. If I could make a simple policy, I would say no default passwords anywhere. And I always adopt the principle of least privilege. That means that I'm going to create special user accounts on the application servers that are used by the technicians. And we don't log in as an administrator to do daily tasks. We configure these systems and we leave them, ideally. These systems are often installed and then not monitored. It's important to check on them. Cybersecurity is an ongoing thing. And we have tools available to let us know if we've been hacked or if somebody is trying to hack. Also, there are plenty of tools to monitor the health of the servers. Are they using too much CPU? Do we need to migrate to a different version of the cloud server? You can use AWS CloudWatch to report on the health of your system, to protect your system from being hacked. It takes time, effort, it's ongoing. We have to think, we have to test, we have to view logs, but all of this to me, is just good cyber hygiene. It will help you and your security and the sustainability of your business. If you have any other suggestions on how building management systems should be deployed to the cloud, I'd love to hear it. Please let me know in the comments. I'm David from Dark Ivy Consulting, and this is Building Management Systems into the Cloud, Well Architected.